So we're going to take a closer look at one of the new properties, one of the new terms that we introduced in this section, which is the pressure that a gas is going to exert. So remember, we talked about pressure being defined as the force applied per unit area, right? So we can say pressure is equal to force over area. And again, this is as a result of collisions of the particles, the gas particles, with the walls of the container. Okay, we saw that the particles, they move around with a certain kinetic energy. They're going to hit that wall. Whenever they hit that wall, they exert a force over that particular area. That is what pressure is. Pressure changes as a result of the volume, changes as a result of the temperature or the kinetic energy, etc. There are different units that we're going to see for pressures. We'll take a close look at some of these. The SI unit of force to begin with in the first place is the Newton, the symbol big N, and 1 Newton is the same as 1 kilogram times meter per second squared. And then the SI unit of pressure itself is the Pascal, abbreviated big P, small a, and this is defined as 1 Newton meter squared. 1 Newton per meter squared, right? So if you think about what that would mean, we can now look at some of the other units of pressure that we're going to see. So typically, we're going to see certain pressure units in chemistry that you may not be familiar with, or that you may have used in previous, either in your daily life or other places. We use what's known as the standard atmospheric pressure, which is abbreviated ATM. Okay, so ATM just means atmosphere. And this is the pressure at sea level, and that's defined as 101,325 pascals, which is the same as 101.325 kilo pascals. And if you think about, where that pressure comes from at sea level, if you can imagine this here being the surface of the Earth, right? The atmosphere extends from, let's say, sea level all the way to the top of that atmosphere. Okay, this is the atmosphere. It's a very thin layer around the Earth. And if you're standing at sea level, you actually have a column of air pressing down on you from the top of the atmosphere to the top of your head, right? And that is what 1 atmosphere of pressure is equal to. Right? If you want to visualize what that actually is. Now, obviously, you don't feel that because you've been alive for however many years. You've gotten used to those gas particles in the air bombarding against you and exerting pressure. But that's what it is. It's 1 atmosphere of pressure. What we're also going to see is mmHg. Okay, and this stands for millimeters of mercury. And we'll see where this comes from in a second. We also have Torr, which is an abbreviation of somebody's name. His name is Torricelli, the inventor of the barometer, which is a pressure measuring device. And then we also have the bar, which is the same order of magnitude as atmosphere, but it's a decimal multiple of the Pascal. Okay, so typically we see millibars instead of bars. So these are the most common pressure units we'll see in chemistry. How is pressure measured? Well, it's measured with a device called a barometer. Again, if you're a fan of weather and the weather stations and following the Weather Channel, they often talk about, high pressure, low pressure systems. How do we know that there's a high pressure low? Well, they actually use barometers to measure atmospheric pressure. And one standard atmospheric pressure, 1 atm, was defined as the pressure that would support a column of mercury that's exactly 760 millimeters or 76 centimeters high. So the idea behind a very simple barometer is as follows. We have this sort of a dish here. We can think of this as maybe like a petri dish. Okay, it's filled with mercury, and mercury is a liquid. Mercury has a symbol Hg. And if this is at sea level, the atmosphere presses down on this mercury, and what it does is it forces the mercury up and into this inverted tube, this sealed inverted tube, and it goes up all the way up to a height of exactly 76 centimeters or 760 millimeters. And then what are we measuring? We're measuring mercury. And that's where the unit millimeters of mercury actually comes from. We can calculate that by using a very simple equation. So pressure being equal to the height in meters times D, which is the density of the mercury in kilograms per cubic meter. And then G is a gravitational constant, 9.8 meter per second squared. Some relationships that we're going to see, you don't have to memorize these, but you're going to see them often enough that some of them are going to stick in your brain. 1 atmosphere, okay, this is standard atmosphere pressure, is equivalent to 101,325 pascals, or exactly equal to 760 millimeters of mercury, or exactly equal to 760 torr, or 1.01 bar. And again, there's a relationship here that you can see. And then maybe another unit that you might be familiar with is 1 atmosphere of pressure is the same as 14.7 PSI. And PSI stands for pounds per square inch. And you often see that in your tires, for example. So that's your P, S, and I. Right? And your tires are normally inflated depending on the manufacturer and the car manufacturer, for example. It's anywhere between 30 and 40 PSI. So that's about 3 times atmospheric pressure is what is in your car tire. Now, when we're measuring pressures other than atmospheric pressure, we use a slightly different device. It's called a manometer. And what the way that this works is that you have your gas sample in whatever, like a bulb here, for instance, a glass bulb, and it's connected to this thing. This is called a U-tube. This is a literal U-tube, not like, the YouTube channels and whatnot. This U-tube here, so when this gas is connected to the U-tube, the gas enters through here, and then it pushes down on the left side of the tube, and there's mercury in here, and it forces the mercury up higher up on the right side, and all you need to do is to take a difference in height from the top of the mercury on the right side to the top of the mercury on the left, and that difference in height is the pressure of the gas, right? And in this particular U-tube, on the right side of the tube, it's actually sealed. So there's actually a vacuum there. Another measuring tool here, another slightly different U-tube. This one actually has both of these open to the atmosphere. So now you actually have atmospheric pressure on the top of this one, whereas in the sealed one, there wasn't any atmospheric pressure. So again, something similar is going to happen. You have the gas coming in, it's pushing down on the mercury on the left side, pushing it up here on the right side. We take the difference, or the height difference here as well. And now because this is open to the air, we actually have to factor in that atmospheric pressure into the total pressure of the gas. It's the height difference in the mercury level plus the atmospheric pressure, because this is open to the outside, right? So that's how these manometers, if you want to pronounce it that way, that's how they work. They use your gas connected to a U-tube, and we just make some measurements in that U-tube. All right, so we can calculate the pressure, for example, exerted by a column of mercury, 70 centimeters high. It says express the pressure in pascals, atmospheres. and in bars, and to give you the density of the mercury. So we can use the P equals the HDG relationship. We're given the height here in centimeters. We want to convert this to meters first. Okay, then we have our D, the density. We want to make sure that's converted to kilograms per meter cubed, and then we're given the so we need G, gravitational constant, and that's a constant as well. All right, so we can substitute those into our equation, and we can calculate our pressure. Once we get it, we can convert it to all the other units using the relationships that we talked about previously.